What if I told you that a machine older than most people watching this video, a machine running on less power than the tiny bulb inside your fridge, is right now floating in a place no human has ever seen with their own eyes, sending back signals that are quietly rewriting everything we thought we knew about the universe? And what if I told you that the scientists reading those signals are not using calm, careful words anymore? They're using words like impossible, terrifying, and we got it wrong. Before I go one step further, if you feel that little tingle of curiosity right now, do me one small favor, tap that like button, hit subscribe, and share this video with one person who still looks up at the night sky and wonders what is really out there. Because trust me, by the end of this, you will look at those stars very differently. Now let me take you back, way back, to a warm morning in September of 1977. A rocket rises from Cape Canaveral, and sitting on top of it is a spacecraft called Voyager 1. It is roughly the size of a small car, wrapped in gold foil packed with cameras, sensors, and a nuclear power source. The mission plan on paper looks almost humble by today's standards. Fly past Jupiter, fly past Saturn, snap some photos, send back some numbers. And then, sometime around 1981 or 1982, quietly stop working and drift away forever. 5 years. That was the entire expected lifespan. The engineers who built it were realistic people. They did not think they were launching a legend. They thought they were launching a very clever science experiment with a short shelf life. What actually happened is one of the strangest, most beautiful stories in human history. And most people walking down the street today have absolutely no idea it is still going on. Voyager 1 reached Jupiter in March of 1979 and beamed back close-up pictures of that giant world that made scientists gasp. Storms bigger than Earth, moons with volcanoes, rings nobody knew were there. Then it swung past Saturn in November of 1980, using each planet's gravity like a slingshot, gaining speed, gaining distance, pushing further and further out into the cold. And then, quietly, it just kept going. Nobody told it to stop, and it did not know how to. By the late 1980s, it had already flown deeper into space than anything humans had ever built. And still, that faint whisper of a signal kept coming home. Now here is where the story stops feeling like a history lesson and starts feeling like something out of a dream. In August of 2012, 35 years after that launch, Voyager 1 did something no object made by human hands had ever done before. It crossed a boundary called the heliopause. And if that word sounds strange, let me explain why it might be the most important boundary you have never heard of. Picture our sun for a moment. It does not just give us warmth and light. It constantly blows out a river of charged particles in every direction, in what scientists call the solar wind. That wind rushes outward, pushing against the emptiness of space, and it forms a huge invisible bubble around our entire solar system. Inside that bubble sits every planet, every moon, every asteroid, every human ever born, every song ever sung, every kiss ever given. Everything you have ever known is inside that bubble, the edge of it, where the solar wind finally gives up and gets pushed back by the pressure of the wider galaxy, is the heliopause. And in 2012, Voyager 1 pushed through that edge and popped out the other side. It became the first physical object from Earth to actually leave our solar system. Not in a poetic way, not in a metaphorical way. Really, truly, gone. And then, incredibly, it just kept talking to us. Right now, as you sit there breathing, there's a working instrument built during the disco era, floating in the space between stars, whispering back tiny pieces of information across 15 billion miles of nothing. And here is the twist that made the entire scientific community sit up straight in their chairs. Because for decades, before Voyager ever crossed that line, the smartest minds on Earth had built careful mathematical models describing what interstellar space should look like. These were not wild guesses. These were beautiful, peer-reviewed, painstakingly built predictions. And they all pointed to a similar picture. The space between stars, they said, would be calm, thin, cold, sparse, mostly boring, like a quiet hallway between two rooms. Voyager 1 stepped into that hallway and found a storm. Starting around 2017, one of its instruments, a plasma wave detector still running on that ancient hardware, began picking up something nobody had predicted. A soft, steady, constant hum in the fabric of interstellar space. Not a one-time flash, not a burst of noise. A persistent, ongoing signal that kept humming year after year. Just to put that in perspective for you, the distance from Earth to the Sun is about 93 million miles. Voyager 1 has now heard this mysterious hum stretched across a region 10 times wider than the distance between us and our own star. And when researchers finally published their findings in Nature Astronomy, they did not tiptoe around it. They said clearly that interstellar space is not the smooth, silent void we imagined. It is turbulent. It has structure. It has texture at every scale. It has, in a very real sense, weather. And every single model built from inside our tiny warm bubble had missed it. Now, take a breath and let that sink in. Every idea we had about what the universe looks like beyond our doorstep was built by scientists sitting inside a planet, staring outward through telescopes, doing math in warm rooms. And now the very first machine we ever pushed past the door is telling us, gently but firmly, that we were wrong about a lot of it. And here is where this stops being a distant space story and starts touching your life directly. Because that bubble, the heliosphere, is not just some abstract idea on a chalkboard. It is a shield, a real physical protective shield that blocks the most dangerous radiation. It softens the blows. It keeps the DNA in your body from being shredded every day by cosmic rays that would otherwise cook the surface of our planet. And Voyager 1 is telling us that the environment pressing against that shield from the outside is more energetic, more chaotic, and more unpredictable than we ever realized. What does that mean for us long term? Honestly, we do not fully know yet. But the fact that we now have to ask the question at all changes something about how safe we should feel. Before I go deeper, I want to ask you something. If you are still with me, if your mind is buzzing right now the way mine was when I first read about all this, do me a small favor. Pause for 2 seconds and drop a comment below with just one word that describes how this makes you feel. Curious, small, amazed, scared, whatever it is. I read every single comment, and it truly helps this channel grow so that stories like this can keep reaching people who care about them. Now let me tell you something almost nobody knows. Because before we even get to what Voyager found at the edge, we need to talk about the moment it almost died. In late 2023, everything went wrong. For 5 long months, Voyager 1 kept transmitting a signal back home. But when the team at NASA's Jet Propulsion Laboratory looked at what was arriving, their hearts sank. The data was gibberish, random, scrambled, meaningless. Decades of experience, thousands of hours of reading this spacecraft's language, and suddenly they could not understand a single word of it. It was like getting a phone call from a loved one and hearing only static. When they finally traced the problem, it was almost heartbreaking in its simplicity. A tiny memory chip inside the spacecraft, no bigger than a fingernail, had physically worn out after nearly 50 years of being pounded by cosmic radiation. One little chip, built in the 70s, had finally cracked under the strain, and now it was scrambling everything the spacecraft tried to say. Normally, when a chip breaks, you replace it. You unscrew a panel, swap the part, tighten a bolt. Done. But this chip was 15 billion miles away. There was no rocket that could reach it. There was no astronaut who could fix it. There was no repair truck coming, and the only tools available were radio waves traveling at the speed of light. And even light itself took 22 hours to get out there. Think about what that means for the people trying to save it. You send a command. You wait 22 hours. You get a response. You wait another 22 hours for the next reply. Every single test, every single attempt, every single tiny experiment took a minimum of 44 hours to complete. And one wrong command, just one, could kill the mission forever. There was no undo button. There was no Control Z. If you made a mistake, that little machine you had loved and cared for since 1977 would go silent, and you would never hear from it again. The team worked through this for months, slowly, carefully, patiently, like a surgeon operating in slow motion through a window that only opens once every 2 days. And somehow, unbelievably, they did it. They realized the broken chip could not be repaired, but the software stored in it could be moved. They took the important code, broke it into small pieces, and carefully placed those pieces into other working sections of memory across the spacecraft. Then they stitched them back together, tested them, and prayed. In April of 2024, Voyager 1 came back to life. Clean signals, readable data, complete science. It had crawled back from the edge of death, from a coma nobody thought it could recover from. And the very first thing it started sending home again? More of that mysterious plasma hum. More evidence of that turbulent alien space that the models had never predicted. The old machine wanted to keep talking, even after nearly dying, even after nearly 50 years, even after we had almost given up. Now let me take you into the moment that broke physics, because as strange as everything I have told you so far may sound, the biggest shock came in 2012. For decades, the models had described what that crossing should look like. A slow fade, a gentle transition, the solar wind thinning out gradually, the interstellar medium quietly appearing, like a river easing into the ocean, one blending into the other, smooth and calm. That is not what Voyager found. At the edge of our solar system, particles were not calmly slowing down. They were racing at speeds close to a fraction of the speed of light. They were smashing into each other with such energy that temperatures shot up to nearly 30,000 degrees Celsius. Let that sit for a second. 30,000 degrees. Not near a star, not inside a sun, at the outer border of our solar system, in a place that was supposed to be cold and empty. Some scientists have started calling this region a wall of fire, and they do not mean fire the way we know it here on Earth. They mean a genuine invisible barrier of ultra-energetic particles standing at our doorstep. But wait, because there is more. There is the magnetic story. For decades, one of the oldest predictions was that magnetic fields would be separate. Voyager 1 found something else entirely. It found that these two magnetic fields, ours and the galaxy's, are actually connected. They lean into each other. They exchange energy. They rearrange themselves in a process called magnetic reconnection, releasing bursts of energy at the boundary. Our solar system is not sealed off. It is holding hands with the galaxy. It is whispering to it. It is being touched by it. And every model built before Voyager crossed that line had completely missed this quiet, ongoing conversation. This is not a small correction. This is a fundamental change in how we understand our own home, because if the relationship between our solar system and the galaxy is active, we must rethink safety. Now let me pull you into the present, because the story does not stop in 2012, or 2017, or even 2024. It is happening right now, in 2026. The clock is ticking louder than most people realize. Earlier this year, the team at NASA had to make a decision that broke a few hearts. They had to shut off one of Voyager 1's scientific instruments, the low-energy charged particle detector, which had been running since 1977. Not because it was broken. It was still working fine. They shut it off because Voyager is finally running out of power, and there's nothing anyone can do to make more of it. Voyager 1 is powered by 3 small nuclear devices that turn heat from plutonium into electricity. When it launched in 1977, those devices produced about 470 watts of power. Today, they produce about 250, and they lose about 4 watts every single year. Somewhere in the early 2030s, the last drop will fade away, and Voyager 1 will go permanently silent. The people who work on this mission have known this day was coming for a long time. They sat down years ago and mapped out which instruments to shut down. Every shutdown is a set of questions humanity will never get to answer. Every shutdown is a door quietly closing. But here's a beautiful little detail almost nobody outside NASA is talking about. The team is not giving up. Right now, engineers are quietly working on something they have been calling, half seriously, the Big Bang procedure. It is an experimental plan to rearrange how power moves through Voyager 1's aging body, hoping to squeeze out just a little more electricity. It is risky. A wrong move on a 50-year-old machine sitting 15 billion miles away could end the mission forever. So they are testing it first on Voyager 2, a slightly younger, slightly closer sibling, before trying it on Voyager 1 later this year. And if it works, there is even a small chance they can turn that shutdown instrument back on. Nothing is promised, nobody is celebrating yet. But they are trying, because with this old machine, betting against it has never once paid off. And speaking of trying, if you have made it this far into the video, you already know this is not the kind of story you scroll past. So instead of asking you to like or subscribe like everyone else does, I am going to ask something different. Send this video to one person tonight, just one. A friend who loves space, a parent who used to point at stars with you, a younger sibling who has never heard of Voyager. Because stories like this deserve to travel just as far as the spacecraft they're about. And now, let me tell you about a date that is already circled on the calendar, a date no human civilization has ever reached before. On November 18th, 2026, at exactly 16 minutes and 12 seconds past 2 in the morning Pacific time, Voyager 1 will cross a major line. It will reach a distance of 1 full light day from Earth. That means that if you send it a message at the speed of light, it takes 24 hours to arrive. If you send a command on Monday morning, it will not reach the spacecraft until Tuesday morning, and you will not hear back until Wednesday morning. 2 full days of silence for a single hello. No human-made object has ever been that far from home. And that milestone will happen while Voyager 1 is still alive. Still whispering, still trying. And then it will keep going. Every hour it moves another 38,000 miles deeper into the dark. The delay will keep growing. The power will keep dropping. And someday soon, likely in the early 2030s, its last signal will be sent. It will travel for 24 hours through the darkness. It will arrive at a big radio dish on Earth, and quietly, without any warning, be the last thing it ever says. But even after that, Voyager 1 will not stop. There is nothing out there to stop it. No wind, no dust, no gravity strong enough to matter. It will just keep gliding forward at 38,000 miles an hour in a straight line into darkness that has no end. And bolted to its side is something that will outlast the spacecraft, outlast NASA, outlast the pyramids, outlast the continents. The Voyager Golden Record. A shiny, gold-coated disc filled with greetings in 55 human languages. The sound of rain hitting leaves. The sound of ocean waves crashing on a beach. The sound of a mother kissing her child. A baby crying. A human laugh. 90 minutes of music from every corner of Earth. Beethoven, Chuck Berry. Traditional songs from India, Japan, Peru, and Bulgaria. A diagram showing whoever finds it where our little blue planet sits in the galaxy. Carl Sagan, one of the people who helped build the record, called it a message in a bottle thrown into the cosmic ocean. And that is exactly what it is. Because whoever finds it, and I truly mean whoever, That record will tell them one true thing: that we were here, that we were curious, that we reached, that we built something out of metal and wires and dreams, and we pushed it out into the night, carrying the sound of our own laughter. That record will still be traveling long after our sun swells up into a red giant and swallows the orbit of the Earth. It will still be moving after every book we have ever written has turned to dust, after every city we have ever built has crumbled, after every name we have ever carved into stone has faded away. It might be the most permanent thing our species has ever made, and it is riding on a machine that runs on less power than the light above your bathroom mirror. Now, come back to the science for a moment, because there is one more thing Voyager 1 is doing right now that deserves your full attention. That persistent plasma hum, the one it has been picking up since 2017, is not just a curiosity. According to the scientists studying it, it is the very first continuous real-time measurement of the space between stars that humanity has ever had. Before this, scientists could only grab quick snapshots of interstellar space, triggered by rare events like giant solar storms. It was like trying to understand the weather of an entire continent by checking one thermometer once a year. But this hum, this soft, ongoing signal, is a live feed, a running portrait of what interstellar space actually looks like from the inside. And that portrait shows us something magical. The space between stars is not empty, it is not silent, it is not still, it has motion, it has structure, it has patterns stretching for millions of miles. It has a personality, a voice, a rhythm. And after thousands of years of staring up at the night sky and imagining what was between those stars, we are finally listening. But even now, with all this data, one huge mystery remains. The scientists analyzing that hum still cannot agree on what causes it. There are two main possibilities. The first is that it comes from tiny natural vibrations in the plasma, called thermally excited oscillations. The second possibility is far more interesting. It could be something called quasi-thermal noise, which would redraw our entire picture of space. To figure out which one is correct, we need more data. But Voyager 1 is producing less of it every year, and there is no other spacecraft coming. No new mission is currently funded to fly out to interstellar space. Even if one were launched today, it would take at least 25 years just to reach the boundary. Which means when Voyager 1 finally goes silent, that window we opened in 2012 will slam shut, and it will stay closed for a generation. That silence is coming. Not this month, maybe not next year, but soon. And once it arrives, we will not just lose a spacecraft. We will lose our only pair of ears in the space between stars. Now, I want to leave you with something in the back of my mind. Right now, in 2026, the only living scientific instrument humanity has ever placed in interstellar space is nearly 50 years old. It was built before personal computers, before mobile phones, before the internet, before most of the people alive today were born. It is powered by less electricity than the small bulb in your kitchen. And it is still teaching us things that giant telescopes cannot. We have built bigger machines. We have built more powerful ones. And none of them have told us what this gold-wrapped machine is telling us. Because none of them had what Voyager 1 had, the stubbornness to keep going, the patience to reach a place no one else has reached. There are questions about our universe that can only be answered from inside it, not from a rooftop telescope or a satellite in orbit, only from a machine brave enough to cross the edge and enter the dark hallway between stars. We only have one such machine. It is old. It is dying. It is running on 4 watts of power, and every single day it sends us a little more of the truth. So the real question is not what Voyager 1 will find next. The real question is whether we are still paying attention. Because when that final signal arrives, 24 hours late, and we play it back for the last time, it will not just be the end of a mission, it will be the end of a conversation. A conversation that began on a September morning in 1977, when a group of engineers pointed a tiny craft at the stars and pressed a button, hoping for 5 good years. And somehow, incredibly humanly, got half a century of miracles instead. If this story moved you, do not let it stop here. Hit that like button, share this video with someone who believes in wonder, and let me know what you think Voyager 1 is trying to tell us. Because one day soon, that little machine will stop speaking. And when it does, we will finally understand that the greatest thing it ever carried was us, our reach, our courage, our questions. And somewhere out there, moving silently through the darkness, a piece of who we are will keep traveling, long after we are gone. Still going, still listening, still whispering back the sound of human laughter.